Now, today's session on power quality, very important topic. As an energy auditor or energy manager or utility manager in the industry, you must aware of this thing. Though you are a mechanical engineer, but our most of our devices, mechanical devices like like pump, compressor, then blower, fans in the industry, cooling tower, motors of the cooling tower, fans, everything is everything needs electricity. And as a mechanical engineer or the maintenance manager, if you work in the industry and if you are dealing with compressor, cooling tower, HVAC, all that stuff, this is you need to you must know at least the basics of electricity and the power quality, so that you can have a overall 360 overview regarding the devices you are handling with or you are in charge of, right? So power quality, so let me start with what is power quality and its significance in the industry. And first, the electric power quality, I always say that we all know that, or we discuss lots of time when it comes to pollution. We discuss about water pollution and air pollution. Okay. And third parameter nowadays also the land quality. Just
Kale sir, hello Kale sir. Kale sir, you are not audible. Kale sir,
sorry, sorry for interruption. uh,
audible not.
okay, so sorry, I
Yes
was
I,
discussing
yes
about
I.
the
Okay.
pollution, air pollution, water pollution and land pollution. And when it but do you know the fourth pollution that is nowadays discussed in the industry is the electricity pollution, or which is called as the power, polluted power. We are using the term that is a polluted power. So power is also gets polluted. So how power is gets polluted? Like when like in case of water, you are asking the municipality or the government that supply us a fresh or the pure water. Sorry, not fresh, pure water, and which is free of impurities and all that stuff, right? Likewise in power industry also, the customer, as a customer, we can ask the utility or the electricity board that supply us a pure power. Okay. The power which is uh, which doesn't have any uh, impurities in that. Okay. So what is mean by this power, polluted power or the power pollution in the electricity, and what is the impurities in that uh, power, that we'll discuss now, right? So I hope these analogies will help you to understand and to create an interest regarding how electricity get polluted and how this polluted electricity is affecting your instruments, right? So let us begin the discussion on this power quality and the polluted electricity, right? So electric power quality, the poor quality of electricity is because of improper wiring, right, incorrect grounding, and unbalanced load that can produce electric noise in an electric system and compromise the power quality. So in short, the improper wiring or grounding and unbalanced load that we'll see in a while what is mean by unbalanced load. But remember that I hope you get some idea regarding the balance and unbalanced loads. And when it comes to the basics of power, I think last time we discussed that the inductive loads and resistive. There are two types of load: inductive and resistive loads. So resistive loads generally doesn't make any distortion, but when it comes to inductive loads, and there are lots of inductive loads in the industry, and these inductive loads like motors are unnecessarily producing or unnecessarily results into unbalancing of the load. And there is another way of unbalancing is the phases. We know that three phases are yb. These three phases are also sometimes not a balance. Some phases over loaded and some is underloaded. So we'll see how this is done. So these are the basic example which results into power quality distortion, and some loads are also responsible for that. When we'll discuss harmonics in detail, at that time you I will give you some examples, and we'll amuse that, oh, these devices that I'm going to use in day-to-day life are affecting the power quality. We are actually polluting the river. When it comes to water, suppose your water from bathroom or kitchen is polluting the fresh water bodies, then you can say, oh, I'm polluting the water body or water. But for electricity, we are also responsible, and some industries are also responsible for polluting the electricity. But as in case of water pollution or air pollution, always uh, not only the one who is polluting that particular source is uh, the get affected. All of the others in that particular network gets affected. Like air pollution, I am polluting air, will not harm only to me, it will harm everybody around me or in this near surrounding, because this is not a phenomena related to individual. Okay, so like the same rule apply to electricity. If I am polluting the electricity, will not affect my network or my utilities, it will affect all the other utilities connected on all the other customers connected on that network, right? So that's why power quality is very much important, and you have to ensure that. Okay, and the second thing is that when I'm going to connect my loads to the supplier or the electricity supplier, I need to uh, ensure that the electricity I'm getting should also be uh, pure, right, or it is of good quality. I'm not saying impure and pure, but you can say that it should be of good quality. And for that, nowadays lots of awareness is created among the customers and industry to improve the power quality or to check the electricity before you are connecting your devices to it. So why power quality? Of course, to minimize the risk of loss of production and damage to electrical equipment. Nowadays your lots of electrical equipment and very critical, in some cases very critical machines are connected to your electricity grid. And if you are getting bad quality or poor quality electricity, that may damage to these electrical equipments. And these failed electrical equipments in now and then results into loss of production, right? And the power quality analysis, that's why one of the example is hospital industry. You can say that important ICU units and the electric various equipments in these units are collect in critical sections of the hospitals are connected to the grid. And if the power quality means over voltage, sudden under voltage, uh, all these results into failure of this critical equipment and ultimately damage to this electrical equipment. And you can just imagine that your ventilator is just got damaged because of the poor quality, and it will affect that the patient which is connected to that ventilator. So that's why power quality is very important. And when you are connecting, suppose you are having the special purpose machine in your industry which cost crores of rupees, and you're if you are connecting with it to the electricity board or the power supplier, and power quality is of not consistent, and it's continuously over voltage, under voltage kind of phenomena occurs. So that may damage to your equipment yet, or your machine, special purpose machine, which cost crores of rupees, right? So that's why power quality study, power quality analysis, scanning, you need to do periodically, not daily. If not possible daily, at least periodically the industry need to check the quality of power they are getting. And so in order to minimize the risk of production and damage because of the failure of the equipment, then power quality analysis is used to monitor the system problems, find causes and corrective actions. Means for preventive maintenance point of view also, power quality is very important. Because if you are periodically checking the it's like checking your body checkup every year. Okay, do your body checkup every year for sugar, bp and all other parameters. uh, and why it is so? Because you can have a preventive maintenance after uh, doing some or treating the illness after diagnosing is the different thing, right? But preventive maintenance is very good thing. So like our health body checkup, you can have if you are having the power quality checkup periodically, you can have a preventive checkup for your critical equipment that I was discussed few minutes back. So remember that power quality checkup will also helps to diagnose the problem beforehand, and you can correct it before your equipment gets fail. And after system data is collected in the field, power quality engineer will look for unusual events and determine the proper conditioning equipment. It will suggest, like a doctor will suggest you, yeah, so your sugar is now on the boundary, and if you will not take a corrective action, you may have a sugar problem, right? Likewise, this power quality engineer goes to, generally these are the electric engineers, and they will suggest you some conditioning equipments. These you need, you have to install in order to avoid damage that is going to happen to your utility, right? So I hope the power quality is covered. So before understanding what are the different in discrepancies in the power quality, you must know what is the ideal power is all about. First we know what is the water with pure water, what is meant by pure water. Then we'll discuss how in what is the impure water looks like, and how it will affect the system, right? So first of all, ideal power condition. So what is the ideal power condition? So ideal power condition is or which is also called as a clean power, right? Because now we are discussing in terms of pollution analogy, so you can call it as a clean power. I'm getting clean power in for my industry or from my supplier, that is good. So what is mean by clean power? So clean power is the power where voltage and current waveforms are relatively in phase, okay, which which is free from distortion and balance between each other, right? So for that, just see this um, diagram or the graph, and which shows the sinusoidal waveform three phase AC power system, an ideal three phase power system where voltage and current waveforms are in phase, free of any distortion. A clean lines, clean sine wave is observed here. And of course three phases are space equally spaced, 120-degree apart and at each to each other, so no unbalance, okay, equally. You can see that these three phases are equally spaced in as 120 degrees to each other, right? And so this is called as a ideal power or clean power, clear, where there is no distortion in voltage. They are the voltage, the phases are equally spaced, okay. And what it shows, the current is in phase. And next feature of the ideal power is the current is in phase with the voltage, that is the power factor is 1 in this case, right? And the source impedance is 0, so that event at load don't affect the source voltage, right? So impedance, no impedance load or no impedance in the circuit, which ensures that it will not affect the source voltage. And actual frequency is equal to normal frequency. Finally, ये सब अगर phase में है तो your frequency is the normal frequency like 50 hertz, so you are getting equally 50 hertz plus or minus point 1 here and there. But uh, this is the features of ideal power or clean power. So here onward, whenever I say clean power or good quality of power, so always remember that clean power, ideal power, good quality of power is nothing but the power where power factor is 1, where the voltage and currents are exactly 120-degree apart and are spaced equally in all the three pages, and voltage and current sine waves are not distorted or interrupted in any way. The source impedance is zero. And finally, the frequency, actual frequency is equal to your nominal or normal frequency. Understood? So these are the features of ideal or clean power. Next, let us begin the discussion on uh, poor quality. What is mean by poor quality or bad quality of power? So what are the different uh, events that you can observe in case of bad quality or poor quality of electricity, right? So there are the most type of power quality problem occur that I am going to start with is the power interruption. Most of the time, the you are getting the electricity or the power from uh, the supplier, and which is generally where you can observe the frequent power interruptions. Okay, and these fewer power interruptions are categorized into three types. One is momentary interruption, second one is a temporary interruption, and third one is a sustained interruption. Okay, the difference is that in momentary interruption, the complete loss of voltage on one or more phases of the conductor for a period of zero point 0.5 cycles or and 3 seconds, or the momentary cycles are up to 3 seconds. In most of the cases, this momentary interruption, you will not uh, feel that, or you will not uh, get that there is any interruption, because this momentary interruption, as the name explains, that it is a momentarily, and it is only for 5, zero point 0.5 cycle or 3 seconds. And I think the thumb rule that we know that in 3 to 4 सेकंड, मोर देन 3 to 4 सेकंड अगर इंटरप्शन है, तो इन मोस्ट ऑफ द डिवाइसेस वो इंटरप्शन आपको फील भी नहीं होगा. क्लियर? सो दैट मोमेंटरी इंटरप्शन विल not affect for few devices, but for, again, remember that I'm not saying at all it will not affect anything, but for few devices you will not get any your operation will not get affected. But in some very important devices, like I explained in hospital industry or microprocessor based devices, where it may affect the performance. And you can remember that or you can imagine that, suppose in case of a bank server. So bank server, if they are having this momentary or temporary uh, interruption, then for a moment or in second, lakhs and crores of transitions are taking place through that bank server, and the momentary power interruption may affects or may results into crores of rupees of loss. Clear? So this power interruption momentary, then temporary power interruption, that is up to 1 minute, and sustained power interruption is loss of voltage for more than 1 minute. Okay, then you can call it as a sustained interruption, right? Power interruption is because of the lightning strikes, then utility switching operations, or maintenance operations by the utility, then physical damage to lines or human errors. Okay, physical damage to power line generally in the season of monsoon. These power interruptions, sustained power interruptions, is quite visible. And in case of lightning strikes, as you can say that if lightning strike is there, that also results into power interruptions. Okay, and as you can see in this graph, that, or in this waveform, that this momentary, then temporary and sustained uh, interruption is shown here as per the IEEE 1159 standard. This is classified as momentary, temporary and sustained interruptions, right? This is the first type of call it. And if this event occur because of, as I told you, some seasonal or some because of the maintenance, then it is fine. But without any seasonal variation or the natural calamity and all that, your power supplier is not supplying you, and this power supplier is having frequent interruptions, then you have to first raise the complaint with that power supplier. Or sometimes nowadays, as we discussed, that you can have a option to change your supplier also. Clear? But not for our domestic thing, and Nasik at least it is not possible to change the supplier. But for a large industry where open access is possible, and they can purchase the electricity from the other private player, they can think of replacing, or think of having the new connection or the open access with the new supplier, which supplies them a clean power or uninterrupted power. Next is under voltage and over voltage. The second most type of phenomena occur in case of electrical industry is the under voltage and over voltage, where voltage at the loads drop below minimum rated voltage, or that is under voltage. And in some cases the voltage climbs above the maximum rated voltage for some time. So this phenomena is the under voltage and over voltage. So this under voltage is nothing but it occurs, you can say, under voltage takes place when RMS voltage drops root mean square voltage drops below 90% of the nominal RMS voltage and stays at the level for more than 1 minute. So remember that the value of the voltage, RMS voltage, nominal or true RMS voltage is below 90%, and it it is, and that uh, voltage drop is for more than 1 minute, then you can call it as a under voltage. The term brownout often refers to an intentional or unintentional drop in voltage in an electrical power supply system. So the under voltage is also called as a brownout. Clear? But you can, under voltage is simple term. So your voltage drop below 90% than the RMS or true RMS voltage, then you can say it is under voltage. Over voltage is of course reverse of that. Is if your RMS voltage is above 110% of the nominal, or your RMS voltage is more than the nominal voltage by 10%, you can say. So 110% of the nominal RMS voltage, and time is of course more than 1 minute, then you can call it as it is a over voltage problem. Clear? So first graph on this side I'm pointing here is the under voltage phenomena. As you can see that the normal green sinusoidal waveform shows the nominal voltage waveform. Clear? But the red shows the under voltage, the frequency, uh, sorry, not the frequency, the amplitude is, as you can see, that is reduced in case of smaller sinusoidal waveform. On the right hand side, over voltage is shown, where the in over voltage you can see that the nominal uh, waveform, sinusoidal waveform for the given utility is like this. But suddenly over voltage takes place, means RMS, your voltage value is now more than 110% than the true RMS voltage. Then red spikes in the as shown here. And if it is sustained for more than 1 minute, then you have to be careful. And in most of the cases nowadays, the remedy to is that we are having voltage stabilizer, right? Your refrigerator, in case of at your house. Okay, as you remember in your childhood, or we remember that lots of television sets or refrigerators in some cases gets burn out because of the over voltage problem. Okay. And the reason, but now then we install one voltage stabilizers at our house. Every TV is having fitted with stabilizer voltage, we call it as a voltage stabilizer above the television set. And that stabilizer is having this voltage protection system. If their over voltage or under voltage takes place, the stabilizer cut off the power supply to the TV so that the TV is safe from burning out, right? So such type of voltage stabilizers are nowadays, these stabilizers are already installed, but there is no need to separate them, purchase them separately. It is already installed with the your TV or refrigerator. When you're going to purchase, you will not see it extra attachment. It is inbuilt in your devices nowadays, right? Next, and I think this is the last term that I'm going to discuss, and we'll continue for the rest of the terms in the next lecture, right? The next term is sags and swells. Okay, sags is occurs when RMS voltage decreases between 10% and 90% for a duration of a half cycle to 1 minutes. So this is called as a sagging. Okay, and sagging in first voltage sinusoidal waveform, you can see that this red is color voltage, or this red sinusoidal waveforms are occur. So such type of phenomena is called as the sagging. Okay, and decrease between 10 to 90% for a duration of half cycle to 1 minute. Okay, agar duration ये 1 minute तक है, where your voltage drops between 10 to 90%, then it is a sagging problem. And one is the swelling, where increase in RMS voltage is over 110% for a duration of up to 1 minute. So this is the swell. So sagging and swelling. Then reduction in voltage. Okay, remember that. Okay, before that, let me finish this, then we'll compare the sagging with under voltage and over voltage. Then reduction in voltage and sags usually occur when RMS current to load increases significantly. So I think for that you must know the Ohm's law. Okay, so P is nothing but V into I, and this V and I, the correlation between V and I is that whenever your voltage drops, okay, your current increases. Okay, in most of the cases, the loads at the load side, suddenly because of some malfunctioning of your load or your devices or appliances, these devices will suddenly uh, in, uh, draws more current. Okay, or they ask for more current, and because of that, if you're having same power, but for the same P you are drawing more I, means your voltage drops. So such event occurs known as a sagging. Clear? But this is phenomena is up to 1 minute only, not more than 1 minute. Clear? And there are three categories of sagging. Same for swelling, apply the same analogy, but in the reverse sense, that in sagging it reduces and in swelling it increases. Clear? So zero point 0.5 cycle to 30 cycles tak agar ye hai, to it is instantaneous. 30 cycles to 3 seconds it is a momentary, and 3 seconds to 1 minute it is a temporary. Clear? So such type of sagging and swellings can occur, and minute, more than 1 minute this phenomenon occur, then it is a, it comes under the sustained under voltage and over voltage. So remember that in case of under voltage and over voltage, more than 1 minute is important. And here you can see that it is up to 1 minute. Such type of fluctuations if you observe, then it is a sagging and swelling. And if it is more than 1 minute, then it goes to, it is not called as a sagging and swelling, it is called as a under voltage and over voltage. So remember the difference. The phenomena, by observing visually, you can, it looks same, under voltage, over voltage, and sagging and swelling, but the difference is the time. Okay, if it is less than 1 minute, then it is such type of spikes or such type of irregularities is in the sinusoidal waveform is less than 1 minute, then it is a sagging and swelling. And more than 1 minute, it is a the under voltage and over voltage problem. Next is flicker, transient, and noise. Okay, I think this is the last term, then I will stop. The flicker, transient, and noise is the repetitive voltage reductions in lighting circuits can be. Okay, so for that, I think flicker, when it comes to flicker, those you use, or at least know the incandescent lamp how it works, and they are used actually uses the incandescent lamps at their house. They will see lots of time whenever you are going to switch on the mixer at your house, you will see some flickers or some fluctuations in the incandescent bulb lighting, right? So that incandescent bulb which is clearly visible to our eyes is such a phenomena is the flicker. Clear? But this is for momentarily mean when we are using mixer for a few less than 1 minute, then you can observe such type of flickers in the incandescent bulb. Or in a workshop also, whenever the welding, arc welding particularly, whenever the arc welding is started, the person or the operator is operating the arc welding, is welding something, then flickers also the lighting, or lighting inside that workshop is also particularly the incandescent bulbs are flickers, they just flicks out. Clear? So these flickers are shown here in this diagram. As you can see that a blue sinusoidal waveform of the voltage, but the red indicates, the red color in that shows the flickers in that, means voltage drops, but that drops is a very small variation in the amplitude of the voltage, and it is not a straight line. Ideally it should be a straight line, but instead of that, this line, red line, means all the amplitudes of each and every cycle of this AC sinusoidal waveform is not a stable, it is variation. So these variations are because of the sudden operation of the sudden devices like arc welding, electric boilers, industrial motors, photocopying machine, mills, means such devices draws a very high current for a moment, so which results into flicking of the at the voltage, and which can be clearly observed in this sinusoidal waveform, right? And next term is the transients. Okay, transient is nothing but when the spikes are superimposed on a voltage or current sine waveforms ranging in amplitude for just a few volt to several thousand volts. Such transients are the lighting and utility switching typically causes high energy impulsive transients. Okay, so utility switching means, as I told you, motors hai, then lights hai aapka, huge, like in hotel industry where the huge lighting uh, load is there. So such type of loads results into an impulsive transients variation. And while electronic devices like VFD and switching inductive loads causes low energy transient, VFD nowadays are the electronic अगर devices है आपके इसको attach है utilities को, then there is a very low energy transiency can occur, and impulsive transient last anywhere from 50 nanoseconds to more than 1 milliseconds. And oscillatory transients last anywhere from zero point 0.3 milliseconds to 5 microseconds. So this transient phenomena is very short in nanoseconds to millisecond. And I think in the second diagram I'm pointing here is the again sinusoidal waveform, where you can see the transient variation. Voltage is sudden spike in the voltage, but that spike is a very for a nanosecond or a milliseconds, and that you cannot again लोकेट, लाइक इन केस का फ्लिकर यू कैन इजीली सी, आपको इनकैंडेसेंट बल्ब आपके घर में है या फिर वर्कशॉप में, you can easily that flicker phenomena is observed. But transient phenomena is not that you cannot see by open eyes, or you cannot observe, because it is for a very nanosecond to millisecond phenomena. Clear? And as you can see that, but variation, as you can see that, see the surge in the voltage very short for a very short milliseconds of time, variation is too high. So this second transient is shown here. And lastly, noise, we know that noise in sound created by the sound is, we all aware of that, and we get irritated because of that noise. But in electricity also, in power supply also, there is a noise. Okay, and this noise refers to unwanted high frequency oscillations that are superimposed on an alternating voltage or current sine wave. Clear? So these unwanted high frequency oscillations, and they are superimposed over your existing sine wave, then you can call as a, there is a noise. Clear? And this phenomena is usually intensifies by improper grounding and is capable of disturbing electronic devices such as a computer and programmable controllers. Okay, so such a type of, if you are continuously producing your device or electricity is having this noise, okay, electrical noise, I'm let me say, because necessarily you will get confused with the sound produced by your appliance and everything. That noise is not expected. This noise is the in your sinusoidal waveform, as you can see in the bottom diagram or the graph shown at the bottom, voltage versus time. So in this graph you can see that such a variation in sinusoidal waveform is no more uniform. There is a sudden spike or sudden reduction, and this is a continuous phenomena, and this is the noise in the electrical term. ओके, तो आपका पावर क्वालिटी पोल्यूट भी होता है, तो पोल्यूशन का वन वन ऑफ द वे कि उसमें है कि नॉइज प्रोड्यूस होना इन द इलेक्ट्रिकल सिग्नल. Clear? So with this I will conclude today's session. In the next session we'll see again power factor. One of the question is unanswered today. Sorry, we'll answer this in the next lecture because that topic is not covered. My question was how capacitor is reducing the reactive load. Okay, why by installing capacitor in your electrical network on or to the load, how my power factor will improve, right? That question is still not answer, or this is still unanswered. And for that you have to wait for the next lecture. And today we'll only discuss how power factor improve is improved, and how to select the capacitor, where to attach that capacitor in order to improve the power factor and get the benefits of improving power factor. Then we have discussed about the definition of power quality and how this power quality will is defined, and what are the different reasons of this bad or the poor power quality. Then what is ideal power, and what are the features of this ideal power or clean power. Then if you are having the poor quality or bad quality, means what are the symptoms of that poor quality and bad quality. One of the symptom is power interruption, under voltage, over voltage, sagging and swelling, sagging and swelling, flicker, transients and noise in your electric supply. So this is all about power quality, first part of the power quality. In the next lecture, the most important parameter, that is harmonics, that I'm going to discuss. And then we'll see how this power quality is, if this phenomena is for nanosecond, millisecond, so how to record this, who will record this, and how to monitor this. So for that we are having power quality analyzer. So in the next lecture I will show you power quality analyzer, and if possible I will show you the power quality analyzer available in your in our laboratory. And I will show you how this power quality analyzer works and the various connections of that power quality analyzer. So with this I conclude today's lecture. Any question?